Let's take a look at the questions on homework number 15. The first topic is determine if a set of points is a function. Let's think back to what the rule of a function is when you have a set of ordered pairs. The rule is that you can have no repeating x values with different y values. So what we're going to do is we're going to scan only the x values of each list. If they are all unique, then that one is a function. But we want to know which one is not a function. So we'll scan this second one here. Again, there are no repeats, so that is a function. And here, I see a repeating x value. X has an input of -1 and an output of 9. And here, x has an input of -1 but has an output of 3. So that is not a function. No repeating x values with different y values. Again, scan each of these x coordinates and look for repeating x's. We're looking for one that is not a function. We're looking for something that has repeating x's with different y's. And that means it's not a function. This time, we're looking for one that is a function. Each of these x values is unique. There are no x values repeating. That is a function. But for the rest of these, you'll see that they each have a repeating x value. And that repeating x value with a different y value means those are not functions. Let's take a look at the next topic. Let's determine if a graph is a function. In order to determine if a graph is a function, you're going to want to take a vertical line or your pen or pencil, and you're going to want to scan it across the graph from left to right. If you very clearly see your vertical line touching the graph in more than one location, then that means you have failed the vertical line test, because you have two repeating x values with different y values. So if you fail the vertical line test, that means you are not a function. Let's try another one. Again, hold your pencil or pen, scan it across the screen. If you can clearly see that you touch the graph in more than one location, then that means you are not a function. Again, using a vertical line, if it touches more than once, you are not a function. Even if it's a curvy graph, it can still be a function. Like this one here. My red vertical line never touches the graph more than one time. So that means that this graph is a function. Let's take a look at the third topic. Increasing or decreasing, linear or nonlinear. This question asks, on the graph below, which interval, that means which section of the graph, is both increasing, that means it's moving upwards, and linear, which means it's straight, not curved at all. So this section, when you use your eyeballs to read the graph, this section's moving up, this section's moving up, but these two sections are moving down. In addition, this one is straight, but this one is curved. So if we want something that is both increasing and linear, that's this section here. So when does that section start, and when does it end? These are the numbers that you'll need to use for your answer. So it looks like it starts at -9 and it ends at -5. So between -9 and -5 is when the graph is both increasing and linear. take a look at another problem. On which interval, which section, is the graph decreasing and nonlinear? Again, when you're using your eyes to read a graph, our eyes would be going down, then up again, but then down. Okay? So the parts that are decreasing are this section and this section. The part that is not linear is only this section. The question is, when does it start and when does it end? So look carefully at your x values so you can identify that interval between 6 and 9. So you'll notice these are written in inequality notations, where the letter x is in between the two endpoints of your interval. So we said the lowest was 6 and the highest was 9, so that must be this one here. Again, read carefully to find the characteristic you're looking for. It has to be decreasing and it has to be linear. I find this one easiest to identify first. Only this section and this section are linear, and only one of them is moving downwards. So that means from here to there is our interval. So on the x-axis, those numbers are -9 and -6. So when I read through the responses, I'm looking for -9 to -6. All right, let's take a look at the next topic. Drawing a line of best fit. A line of best fit goes somewhere through the middle of your data. So I drew with my pen, but you are going to draw with your mouse or your trackpad. And what you're going to do is you're going to click to plot maybe where you think the line will start, and then again where you think the line will finish. And if you did a decent job, it will highlight for you where their estimated line was. And we were pretty close. Let's try it again. I think I want it to go from here to there. And if I don't like it, I can just click that dot again and twice, and I can start over again if I want the line to be a little bit lower. Let's see how we did. Not too shabby. All right, last two sections. Association. The association is, when you read your graph from left to right, what the general trend of the scatter plot is. So this scatter plot here shows a negative linear correlation. Now, an outlier is when you kind of see one point really lying far away from the rest of your data. I don't really see anything obviously far away, so I'm not going to select that option from the menu. And that's negative and linear, because when I read from left to right, my x numbers are increasing, but my y numbers are decreasing. Again, you should be able to draw a line of best fit, and in this case, if you're not exactly sure which direction the line should go, then you probably need to say that the scatter plot shows no correlation. And that's because there is no pattern. There is no pattern to the points. One more time. These yellow dots seem to be trending downwards, so I'm going to say that this is a negative linear, and that is because they are generally decreasing. Now take a look at this one. It's also decreasing, but look at that yellow dot. It's kind of off in the distance. So we're going to say that this has a negative linear, but it has one outlier, because that one dot seems to be kind of far away. But the reason we're picking negative is because the y values are generally decreasing. All right, let's take a look at our last topic, comparing rates of change. We've done this a few times, and we have different formats. So this is an equation, this is a table, this is a graph. You find the slope or the rate of change from an equation as the coefficient of x, and now we want to find something that has the same rate of change as that equation. From a table, you're looking for the pattern of the y's divided by the pattern of the x's. So it looks like my y is decreasing 12, and it looks like my x's is increasing 2. And negative 12 over 2 is negative 6. So that is definitely not the same as my magic number negative 3. So let's take a look here at our 2 points. We're going to count the rise and the run. And I go down 1, 2, 3, 4, 5, 6, 7. Then I go over 1, 2, 3, 4. Negative 7 over 4. That definitely does not match my magic number of negative 3. So let's take a look at the other 2 options. Looks like this one has an increase of 2, and this one has an increase of 4. So that's 2 over 4, also known as 1/2. Again, that is not the magic number of 3. So let's take a look over here. 1, 2, 3, down 3, over 1. There's the match. So we're going to select letter D, and we're going to do this again with our different formats. This time, we're given a graph of a function, and we want to find a function with a greater rate of change than this one. Well, first, I have to find 2 perfect corner points, and I'm going here. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4. Negative 7 over 4. So I want something that is greater than this. I'm not exactly sure what that is, but I know that if I converted it to a decimal, it would be negative 1.75. So I'm looking for something that's bigger than that. Bigger than negative 1.75. And this one is very obvious. I don't even have to check this pattern here. I don't even have to check this pattern here, because that's a 4. That has a rate of change of 4. And 4 is bigger than negative 1.75. So I can select it, and I can move on. Alright, that concludes our tutorial for homework number 15.